In this video, we're going to discuss complex numbers. So a complex number is the number of the form a plus bi. And you can see that there are two parts here. The a is the real part. The b is the imaginary part. And you can tell that the b is the imaginary part because it is attached to the I, which is an imaginary number. The I is equal to the square root of -1. So prior to this section, when we had the square root of a negative number, we said that it does not exist. And we mean that it doesn't exist in the real number system. But here we're going to add a new number system. We're going to be talking about the imaginary numbers, which takes us to the complex numbers. So now whenever we see a square root of a -1, we will know how to simplify it. We can take that out as an I. The good thing about that is that we can then manipulate the expression or equation that we have because we can use I and treat it as a variable in the sense that we can combine like terms, and it just makes it easier to look at and use. So let's look at some examples. So simplify each radical. So the first thing you want to notice, and you don't have to do it this long way every time. Let's see. The first thing you want to notice is this is a -36. So before we would have just said, oh, this doesn't exist, and then we would have moved on, or would have said not a real number. Really, that's a better answer because it does exist. It's just not a real number. So notice that this is the same thing. So if I wanted to rewrite this, I could rewrite this as -1 times 36. That is equal to -36, right? So that's the same thing. Now, -1, I just said above, is I. So I can take that out of the radical as an I. 36, the square root of 36 is 6. So this is going to be just 6i. So essentially, if you have a negative, the negative comes out as an I, and then you just take the square root of whatever number is there, like you would without the negative. If it's a perfect square, you just take it out of the radical completely. If it's not a perfect square, then you just reduce it as much as possible, and put the I out front with it. So let's look at the square root of -50. So the 50 is not a perfect square. So we're going to try to break that down. So if I use the prime factor tree technique, I can break this down into 5 and 10, and then 10 breaks down into 5 and 2. Remember that pairs come out because that will be perfect square, and the single thing stays under because that's left over. So for 50, if I just had the square root of 50, that would simplify to 5 square root of 2. But since I have this negative out front, I need to take an I out with the 5. So the square root of -50 will simplify to 5i square root 2. Okay? So again, the negative can come out of the square root as an I. Number 3. Here, 1440, I'm not sure if that's a perfect square. We can check on our calculator, right? If you don't know if it's a perfect square, you can always just do the prime factor tree and see if it works out. Okay, it doesn't look like it is. So let's do the prime factor tree. So since it ends in a 0, I know that it's divisible by 10. So I'm going to start there. And then 144 is 12 times 12. And I can keep going with the 12s because those are not prime. But if I see that I already have a pair, I can leave it like that because the pair is going to come out. And the 10 is 2 and 5. So even though the 12s are not prime, I'm going to stop because I have a pair. And that is fine to do. So the pair of 12s is going to come out as a 12. And then the 2 and the 5, those are both prime. Neither of them have a pair, so those will stay under. So a 12 will come out. The negative comes out as an I, and then the 2 and the 5 multiply back together underneath the radical to give you a 10. Okay, now some of your calculators will simplify this for you. If your calculator will not simplify a negative under the radical, then all you have to do is simplify the square root of 1440 without the negative, and then put the I on the outside with the number that's out there. Okay, so now this part is going to be talking about how to deal with complex numbers when you already have the I. So we don't have the square roots in these problems, but remember the I represents the square root of a -1. So perform the indicated operation and express the result as a simplified complex number in standard form. So standard form, you need to remember, is a plus bi or a minus bi. Basically, the real part comes first and the imaginary part comes second. It doesn't necessarily have to tell you that in the directions. That is something that is understood. You should always write your complex numbers in that form. All right, so if you're adding complex numbers, here the parentheses aren't really necessary. They're just separating the two complex numbers from one another. But since it's a plus, it doesn't change anything if you take away the parentheses. And at this point, all you want to do is combine like terms. So the real number parts you can combine because those are like terms. So neither of these have an I, so you can combine them. That's the real part in blue. Okay, and then this part I'm underlining in green, those are the imaginary parts. So you can combine those because they are like terms. So -2 plus 1 is -1. And then -4i plus 6i is positive 2i. And that would be my sum. That's my answer. So if you wrote it as 2i minus 1, although those are mathematically equivalent, that would not be considered correct because it's not in standard form. All right, number 5. Here we have a subtraction, right, a difference. So this is going to be important that we remember to distribute the negative outside of the parentheses. So that's the difference between 4 and 5. Other than that, it's the same. So 2 minus 3i minus 3 minus 2i. And then again, we want to combine like terms. So I have a 2 minus 3, that's my real part. So that gives me a -1. And then -3i and a -2i, when I combine those, I get -5i. And that's it. That's the difference between those two complex numbers. Okay, number 6. Notice that there is not a symbol or an operation sign between the two parentheses right here. So there's nothing here. Remember, in that case, it means you're multiplying. So I'm going to multiply these. That means I need to distribute. So I'm going to take this 4i and I'm going to distribute it to both terms, right, the real part and the imaginary part in that parentheses. So 4i times 2, that's 8i. And then 3i times 4i is 12i squared. Now here you need to know that I squared is equal to -1. Okay? Anytime you have an exponent on an I, you want to completely reduce that. So your answer is not considered simplified if you have any exponent on an I. You have to keep simplifying it. So if you have an I squared, you need to know that that is the same as -1, and you need to replace the I squared with a -1. So now that becomes the real part, and you can see the 2, when we multiplied it by the 4i, became the imaginary part. So this is going to be 8i, and then 12 times -1 is -12. So whenever you have a number attached to an I squared, you're multiplying it by I squared, it's going to change the sign of that number. Okay, this is now not in the correct form. Remember, we want the real part first and the imaginary part second. So we're just going to change the order and have the negative 12 first and the 8i last. And then that is our answer. All right, let's look at number 7. So number 7 is similar. We have this 5 we want to distribute. So in this case, we will have 5 times 6 is 30 minus 10i. Here, there's no exponent on the I because we didn't distribute an I, right? In this case, we just distributed that 5, which is a real number. So it's in the correct order. No exponents on the I, so in that one we're done. All right, number 8. This one we're going to use the distribution property more than once. So some people call it FOIL. We're going to take the 2 and distribute it first. So 2 times 4 is 8. 2 times negative I is negative 2i. Now we're going to distribute the 3i. So 3i times 4 is 12i. And 3i times negative 1 is negative 3i squared. Okay, so a couple of things we need to do here. First of all, we can see that negative 2i and 12i are like terms, so we can combine those together. And then also notice that we have this I squared. So since that has an exponent, we need to remember that that is equivalent to negative 1, and we need to substitute that in. Okay, so we have 8. Negative 2i plus 12i is positive 10i. Negative 3 times negative 1 is plus 3. And now look, we have these two real numbers that we can combine for our real part. So that will be 11 plus 10i. And that is our final answer here. Okay? So this is really similar to what we've been doing with polynomials, right? If we had the x's, we would have x squared. So we're treating this similar to a variable, with the exception that we can't leave an exponent on the I. Okay, number 9. These two things are called complex conjugates. So notice I have the same two pieces, right? The 4 and the 2i. The difference is the middle sign. One is a plus and one is a minus. So those are called complex conjugates. What happens when you multiply complex conjugates is you end up getting rid of all the i's and you end up with a real number. So that will happen every time you multiply complex conjugates. So let's see. If we distribute the 4, we will get 4 times 4 is 16. 4 times 2i is 8i. Now we're going to distribute this negative 2i. So that will be negative 8i minus 4i squared. Okay, so look at the two middle numbers. Do you see that those are opposites? So we have 8i and negative 8i. So those are gone. And then here we have an I squared, and we need to remember to replace that with a negative 1. So that I is gone as well. So now we have 16. Negative 4 times negative 1 is plus 4. And so you can see our answer is 20. So that is a real number, no longer imaginary or complex. So when you multiply complex conjugates, all of the i's go away. They kind of work themselves out. All right, number 10. Remember here, it's easy to forget this. People want to just try to distribute this exponent. It doesn't work that way. Remember that this square means it's two of those parentheses. So it's 9 minus 7i times 9 minus 7i. And then we're just going to use the distribution property like we did before. So that would be 81 minus 63i minus 63i plus 49i squared. Okay, be careful, do not cross out the two middle terms because those are like terms. They're not opposites. So we will have 81 and then the minus 63i and another minus 63i. That will give us minus 126i. And then we have the I squared becomes a negative 1. So 49 times negative 1 is negative 49. Just changes that sign. All right, and now we want to do 81 minus 49. We'll get 32 minus 126i. All right. So we've done addition, subtraction, multiplication. Now we're going to do the division problems. So number 11, we're dividing a complex number by 2. So here what we want to make sure we do is split this apart into real and imaginary pieces. So the real part is the 3 on the top, right? So we can do 3 halves plus 4 halves I. So I'm just taking each number, right, each part and dividing it by the 2. And then I have that I at the end because that's with the 4. And then I can reduce either of these fractions. So 3 halves will not reduce, but the 4 halves will. That will become 2i. So 3 halves plus 2i is how you would write this in simplest form. So now we want to look at number 12. Look at the difference here. Number 12 has an I in the denominator. So this is going to be worked differently than number 11. So if you have an I in the denominator, remember that I stands for the square root of a negative 1. And if you recall in an earlier section, we can't have a square root on the bottom of a fraction. We just don't consider that simplified. We like to rationalize the denominators. So that means we don't want to have an I in the denominator either. So if you have one term on the bottom, it's a pure imaginary number, then what you want to do is multiply just by the I. That will get rid of the I because it'll give you an I squared. Whatever you do to the bottom, you have to do to the top as well. Okay. So on the top, we're going to end up distributing this I. Okay. So we will have negative 5i plus 3i squared over 2i squared, right? Because 2i times I is 2i squared. Now, all of the I squares, those will become negative 1s, right? Okay, so now we will have negative 5i minus 3 over negative 2. Okay, so now we can see that we're getting somewhere. Look in the numerator. That is not in the correct order, so we want to reorder it. So the real part's first and the imaginary part's second. And then the last step, we now have something that looks like number 11. So we're just going to split this apart into the real and imaginary pieces. So negative 3 halves is the real part, and negative 5 halves is the imaginary part. Neither of those fractions will reduce, so that is the simplified form. Okay, the last one is number 13. So this one is different from 11 or 12. Can't quite fit them. Oh yeah, there. I think they're barely on there. Number 12, you can see that the bottom had 2i. That's a pure imaginary number. There's no plus or minuses like number 13, right? This is a complex number because it has a real part and an imaginary part. So this is going to be worked differently. In order to get rid of the I in this case, whenever you have an actual complex number, you're going to have to multiply by the complex conjugate. So we looked at one of those earlier. It's the same two terms, but the middle sign is different. So here we want to multiply by the complex conjugate, and it's always the complex conjugate of the denominator because that's what we're trying to get rid of the I. But whatever we do to the bottom, we have to do to the top. And so now you can see we're going to end up distributing on top and bottom, or foiling, whatever you want to say. So let's see what we do when we get that. So on the top, we're going to have 2 times 4 is 8. 2 times negative 3i is negative 6i. Now I'm going to distribute that negative 3i. So negative 3i times 4 is negative 12i. And negative 3i times negative 3i is plus 9i squared. Over, on the bottom, I have 4 times 4 is 16. 4 times negative 3i is negative 12i. 3i times 4 is positive 12i. And then 3i times negative 3i is negative 9i squared. Okay, so on the top, I have like terms I need to combine. So these two i's here will combine together. I've got the I squared, which is going to become a negative 1. So in the numerator, I have 8 minus 18i, and then the 9 times negative 1 will end up giving me negative 9. In the denominator, the 12i's will cancel out because I have a negative 12i and a positive 12i. And then the I squared becomes a negative 1. So that will end up being a plus 9. So in the bottom, I'm going to have 16 plus 9. All right, so we're just going to keep on simplifying. So I've got 8 minus 9. Those are my real parts. That will give me negative 1. And then minus 18i over 25. And again, my last step is just to separate out my real and imaginary parts. So I have negative 1/25 minus 18/25 I. Neither of these fractions will reduce, so this is my solution.